I'm in the process of repairing and restoring an HP85B computer. I'm currently working on the tape drive, and the tape drives themselves are notorious, or more specifically the tapes themselves are notorious for failing. And there are quite a few videos on the internet, on YouTube, showing how to go about modifying these and repairing them. And I thought I'd also include some methods and techniques I use for repairing these. I've repaired quite a few of these over the years and tried different methods, and the one that I found to be most successful in terms of modifying them for using DC2000 tapes is to make an extended friction roller to drive the tape. So that's fairly easy to do. I've shown how to do that in the previous few videos, and there is also another change that needs to be made to the electronics, and I'll explain why that is in this video. So to start with, if we have a look at the specification for the two tapes, I don't know if you can read this or not. This information is readily available for these tapes. You can see there are a whole range of tapes from the DC100, which is the HP tape that we started with, through 1000, 2000s, up to the 6000 series tapes. And you can see here that the dimensions of the DC100, which is the first one, and the DC2000, the dimensions are the same apart from the thickness of the tape. So it's 0.47 inches on the DC100, and it's 0.57 on the DC2000. So the 2000 is about 0.1 inch taller, and that's why we had to extend the pulley to drive the tape. But there are other differences as well that are important. We can ignore most of it. So for example, we have here the length. They're fairly similar, but we don't need to take any notice of that because the length of the tape is kind of immaterial. The machine doesn't really care about the length. It has marker holes at either end of the tape to tell the machine when it's reached the end of the tape. It doesn't try and keep track of how much tape it's fed through. Also, you'll notice that the capacities difference for the 100 and the 2000, again, doesn't really matter, and most of that is actually by virtue of another couple of the parameters that we can look at. One of those is the number of tracks on the tape. So for the DC100 it's quoted as 2 tracks, and for the 2000 it's quoted as 20. And there's nothing kind of physically marking those tracks on the tape. They don't really exist as such. They're kind of imaginary tracks, and they're created by simply writing a track onto a specific part of the tape. So it doesn't matter if there's 1 track or 10 or 20 tracks, as long as you always pass the same part of the tape over the read-write head, you can retrieve the data. Of course, the extra densities that are quoted for the DC2000 tape, which is, if we look at the recording density, and this is flux transitions per inch, it's 3200 for the DC100 and up to about 12,000 for the DC2000. Now that has an implication that it's a different recording media. That's kind of the nature and the qualities of the magnetic compounds that are made and put onto the tape, and they are different for the two types of tape. So that in itself doesn't cause any problems, but we do need to take that into account when we're trying to use the tapes. So if we look at the column here that's headed nominal coercivity, it kind of means exactly what it sounds like. That's how much effort you have to put in to coerce the magnetic material to change its magnetization state. So the higher this number, the more flux you have to put into the tape to get the magnetic material to change. And you'll notice here, hopefully you can see this, that for the DC100 it's quoted as 310, but for the DC2000 it's 550, so that's significantly higher. So chances are if we try to use the drive unmodified, it would struggle to write the data reliably to the tape because the write current being passed through the head isn't high enough to create a flux density sufficiently strong to properly change the magnetization state on the tape. But it's quite easy to change that. If we get the schematic for the control board for the tape, unfortunately it's very difficult finding spec sheets for these devices. The one we're interested in here though is this one, and again I don't know if this is intentional by HP, but what it's really showing here in the internal workings of the IC is really kind of the read mode of the device, and it doesn't really help us in terms of the write mode, but it's the write mode we're interested in. But in particular what we're interested in here is the WREF, or write reference, and this resistor here sets the write current. That's how much current's passed through the read-write head, which is this, when we're trying to write the tape. The higher the value, the lower the current, and vice versa. So we can make a very rough and ready ballpark estimation as to how to change this value to take into account the different coercivity between the DC100 and the DC2000. This is very rough ballpark, as I say, so you'd need to get the spec sheet and look into this more carefully to get an exact value for this resistor. Luckily we're not trying to create an audio system here, so we're not really that concerned about the dynamic range of the data we're putting onto the tape. This is purely a digital system, so it's going to record a 1 or a 0, so we don't need to be concerned with the dynamic range. If we run the tape head so that it saturates the tape, it doesn't really matter. We'd lose dynamic range if we were trying to record an analog value, but that's not what we're doing. We're either recording or we're not. So the easiest thing we can do, as I say, is make a rough estimation. Now because of the way these circuits work, what we can do is if we divide this value by 2, we can make the assumption that the internal circuits give us a non-linearity based on the value of this resistor, and by dividing by 2 we can kind of take that into account. It's not 100% accurate, but it will give us a fairly good ballpark figure for the resistor value that we need to use here. So we can do that fairly easily. We'll just grab the calculator. The value shown on the schematic is 665 ohms. If we divide that roughly by 2, so we'll call that 300, and we'll start off by working out the ratio of the two values on the coercivity for the two tapes. So if we divide 310 by 550, we get a value of 0.56. So remember that 0.56 is the ratio between the two values, and we can now use that based on the starting resistor value that we have. So if we subtract 300 from 665, we get a value of 365. If we multiply that by the ratio that we've just worked out, we get a value of 204, and then we add the 300 back on and we get 504. So what I'm going to do, the nearest value I have to that is 510 ohms, so that's what we're going to use. So we're going to change this resistor, R1, to a value of 510 ohms. And if we look at the board layout, it's this resistor here, and if we grab the actual board itself, it's hard to see because it's tucked away inside there, but it's this resistor. Looking on the back side of the board, it's this resistor here. So I'm going to swap this resistor with a value of 510 ohms, and that should give us a write current that's going to take into account the specific characteristics of the DC2000 tape media. So I'll get that done and we can then start reassembling the tape drive. I've replaced the resistor, that's now a 510 ohm resistor, and we're ready to start reassembling the drive. So the old resistor, I did check it, it was 665 ohms, so that's the correct one. And the next thing we have to do is to reassemble the motor. So this is just as simple as putting the spindle that we've modified onto the motor. Very small clearance between the backing plate of the motor and the encoder disc. Tighten the grub screws and then I can bolt this back into the drive. So I'll get that done, and also I'll resolder the emitter to the board. That's the motor bolted back in. I've reconnected the emitter for the speed sensor, and what we can do now is try fitting the two tape types. You can see I left 0.5 millimeter gap between the top of the roller and the frame, so that gives us full coverage of the roller, the drive roller, on the DC2000 tape. So what we want is for the bottom part of that roller to engage with the DC100 tape, so we'll try that first. So this is the original HP tape, and when we push this all the way in, you can see that the roller does indeed engage. And now for the crucial bit, we'll try the DC2000 tape. So that fits in quite nicely, and when we push this all the way in, again it engages quite nicely with the roller. If I try and rotate this, we should see the reels on the tape go around, and we do. So that's looking good. The next thing is to get the drive bolted back into the machine. We can then run it up and see if it actually works. I've got the tape drive bolted back into the machine, so we can give it a trial. If you've ever repaired one of these, then you'll probably realise that the tape drive shouldn't make a lot of noise, and when it drives at high speed, that's where really having a very well centred drive spindle is important. If it's not properly centred, it may work, but the problem is if you vibrate these tapes too much, it can cause the problem that we saw earlier of the belt jumping over the tape, and it can cause the tape to actually fail. So really you need these to run fairly quietly. If they're making a lot of noise and vibration when they're running fast, you need to try and fix that, otherwise you can end up destroying your tape. The DC2000s aren't too bad, but the DC100s are very susceptible to vibration, and because the scope they have for the proper tracking of the drive belt is so narrow, it's very easy if these start vibrating for that to go off track at high speed. Okay, so we'll try and power this up, so hopefully I haven't broken it and it should still come back to life. Power light is on. Just wait for the cursor to appear. Okay, we've got a cursor, so the next thing is to try and fit our DC2000 tape into the drive. Shouldn't be any real resistance, and we should be able to slide this in. I'm just looking at the tape cover to make sure it's going down the right slot. This is the first time I've tried to fit a DC2000 tape into this drive, so I'm being very careful, and no resistance. The flap has gone through the opening okay, nothing's binding, so I'll try and push this all the way in. Okay, well that's looking fairly good. Next thing is, as ever, this is a brand new tape, it's never been used, so I need to effectively format it. So we use the erase tape command, and we'll see if this works. So what we're listening for here is any loud noises, any vibration. It should be reasonably quiet, and I've also got the record protection tab in the protected position, so it shouldn't actually let us format or erase this tape. It should come up with an error, but that's just so I can test that the switch is in the right place. It's better doing it this way around rather than making a mistake and putting a tape in that you don't want to erase. So in theory this should fail, so we'll give this a go. Okay, good, so it's recognised the right protect, and also it sounded good. It was very quiet on the rewind, at high speed, and then it was almost silent when it was trying to write. So I'll move the Write Protect slide across, and we'll try that again, and this time it should be successful and it should be able to erase the tape. So I've got the tab moved across. I'll refit this into the machine and we'll try that again. Okay, the first two attempts to erase the tape failed, and it came up with a search error. That's normally because the tape is too slack. So I did a ctape command. It just drives the tape from end to end, and then I tried erase tape again, and this time it succeeded. So again, that's quite a good sign. It means the tape is running fairly accurately. So what I'm going to do now is enter a very short program, and we will try saving that to the tape. Okay, I didn't want to bore you too much with the detail. I've been giving this tape drive a good thrashing. I've tried a couple of DC2000 tapes. Seems to be working fine, and written a short program. It's only 3 lines, so we'll erase that. So we've got nothing now in memory. And if we try and load the program from tape, and as you can see, it's now working fine. Not only that, but the tape is very quiet. There's no vibration, no real noise coming from it at all. It's working very reliably, and as I say, I've been playing with this now for probably an hour and a half. I've been writing to it, reading from it, performing C-tape recondition of the tapes, and running from end to end. It's very nice and quiet. And as I say, I've tried a few tapes. I'll try a few more, but this looks like it's been completely successful. I'm not sure that the resistor value is perfect. I think it might need to be slightly lower than 510 ohms. The reason I'm saying is I put a scope on the signal and it's a little bit lower than I would really like, but I'm going to try cleaning the head. This has had the old tapes running through it, and these do tend to shed magnetic material, so although I clean the head when I refurbish the drive, it may well have been contaminated. I also want to try repairing a couple of the original HP tapes. I've got a few that the band has failed on, and I'll try repairing them, see if it still works with these. No reason it shouldn't, but it is looking very promising. So just to recap, all I did was to take the spindle out, machine it to remove the top drive section, turn that down to just over 5mm, made a pinch roller, and the probably can't see in there, but I'll just bring the light down, hopefully you can see a bit more clearly. The roller is seems to be surviving very well. It's got that nice appearance that you get when the roller's in good order. It's a nice even line all the way around where it's been pushing up against the drive wheel on the tapes themselves. No sign of it moving, and as I say, it's got a nice even finish, and most importantly, when it's running at high speed, it's almost silent, which is exactly what I was looking for. So that's looking quite promising now. As I say, I'll carry on testing this, some test programs that I can run on this to really give the tape a good thrashing, and then I'll start trying to write some very big files to it and see if that works. Okay, so hopefully someone found that of interest. If you've got one of these to repair, there are of course any number of ways you could go about doing this. I tend to prefer this method because it gives a very good long-lasting result, and it gives the machine a very nice kind of feel to it. The methods I've tried before of just putting bits of tubing on there They tend to work, but they do make the machine sound fairly harsh when they're reading tapes, and it really shouldn't. It should be kind of a nice whir sound that it makes when it's running fast. So that's the tape drive working, printer's working, the display's working fine, and all the keys now seem to be working. I had a couple more plungers I needed to replace that were a bit intermittently sticking. Cleaned up the entire inside of the case. So the next thing I want to look at, that I'll look at in the next video, is cleaning up the outer case. I still need to pop off all the keycaps and give those a really good clean. There's still some dirt on some of them, but the outer case, it's not too badly faded, but I want to clean it up and get this machine looking really nice, and then I'll have what I hope will be a fully functional HP85B.